Hello everyone, a very good evening to all. Myself, Vivekananda Naik. I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. I welcome you all once again for this interaction session, which is our fifth interaction session based on the course Solid State Physics, which is being flowed this semester by NPTEL in this July 2024 session with course code NOC 24 PH43. So in this interaction session, we will discuss a few problems that will be based on week 5 of the course content that will mainly cover concepts of reciprocal lattice and some initial concepts related to electrical properties of matter. So let's begin with our discussion. First, this is the first problem of today's session. So the problem says, find the Miller indices of the plane having intercepts on the three crystallographic axes that are A by 2, and C respectively, where A, B, and C are the lattice parameters. The options are options A 1 1 1, option B 1 2 1, option C 2 2 3, and option D 2 1 0. So these are the four options. The question says, find the Miller indices of the plane having intercepts on the three crystallographic axes that are A by 2, and C respectively. So this question is based on Miller indices calculation. So in the previous week also we have solved a few problems that was based on the same concept of Miller indices. So I'll give you a few minutes to try this question and then I will discuss its solution. So let's discuss the question. So the intercepts are now there are three intersect x, y, z. Suppose the A, B, C are lattice parameters. So A, B, C are lattice parameters, and the intercepts are A, A by 2, C. So this is so sorry. This should not be A by 2. This should be B by 2. So this is B by 2, and we know to calculate we need x by x intercept, y by y intercept, z by z intercept. So it will be A by A, B by B by 2, and C by C. It will be 1, 2, 1. So uh, since it is already all are integers, and also we can't find any number which is common to all these three values 1 to 1. So the Miller indices of this particular plane which has intercepts A, B by 2 and C on crystallographic axis will be 1, 2, 1. So the correct option will be option B, that is 1, 2, 1. So this is very simple. Then we will move to the next question. The question says, calculate the angle which the 111 direction of a cubic lattice makes with the 110 direction. So there are two directions. One is HKL, which is 111. Other one is H prime, K prime, L prime, which is 110. So these are the two directions that has been given in the question. And the question says, calculate the angle which 111 direction makes with 110 direction. So simply we can say that we need to find out the angle between the two normal vectors which are normal to this particular sets of planes 111 family and 110 family. So the options are option A 35 degree 15 minute, option B 25 degree 18 minute, option C 45 degree 25 minutes, and option D 55 degree 23 minutes. So these are the four options. We need to simply find out the angle that these two planes or the normals to these two planes make with each other. These are the options. I'll give you a few minutes to try this question and then I will discuss. So if we solve this question, we know if theta be the angle between these two sets of planes, then the formula which will be used to determine the angle between the two planes is cos theta equals to h prime plus k prime plus l prime divided by h square plus k square plus l square root over into h prime square plus k prime square plus l prime square root over. This is simply the angle between the two vectors A vector and B vector. So if we consider one vector is normal to a set of plane having directions 1, 1, 1 and another normal to sets of planes having direction 1, 1, 0, then we can say this is simply A vector dot B vector by A vector mod into B vector mod. This is nothing but this is the formula. So if you put the values, it will be 1 into 1 plus 1 into 1 plus 1 into 0 divided by 1 square plus 1 square plus 1 square root over. So this is root 3 into 1 square plus 1 square plus 0 into root 2. So it will be 2 divided by root 3 into root 2, that is 2 divided by root 6, or simply we can say root 2 divided by root 3. So this will be like this. So cos theta is root over of 2 by 3. And if you check the angles of cosine angles values, so theta will be cos inverse 2 by 3 root over, this is cos inverse 35.26 degrees. So cos inverse cos 35.26 degrees. So this theta is 35.26 degrees. That is 35 degree 15 minutes. And we know 1 degree is 60 minutes. So 0.26 is roughly 0.25 we can say. So it is 15 minutes. So theta will be 35 degree 15 minutes. That is the answer. So the correct option is option A, that is 35 degree 15 minutes. I hope this is clear to all of you because this is pretty simple. We just simply need to calculate the direction between the two, the angle between the two directions that are given. So simply we can put the formula cos theta is equals to A dot B divided by A vector dot B vector magnitudes. So it will be H prime plus K prime plus L prime divided by H square plus K square plus L square root over into H prime square plus K prime square plus L prime square root over. So if you put the values and calculate, you will get the value of theta is 35.26 degrees or 35 degree 15 minutes. So I hope this is clear to you. Then we'll move to the third question. The question says, calculate the distance of the plane 2, 2, 2 from a parallel plane that is passing through the origin of a cubic unit cell of side A. The options are option A by root 3, option B, A by 2 root 3, option C, 2 by 3 root over or 2 by root 3A, or option D, A by 4 root 3. These are the four options. The question said, calculate the distance of the plane 2, 2, 2 from a parallel plane which is passing through the origin of a cubic unit cell of side A. So there is a plane whose Miller indices are given 2, 2, 2. and we need to find out the distance of that plane from another plane which is passing through the origin, which have a the origin of the cube which has side A. These are the four options. So I will give you a few minutes to try this question, and then I will discuss how we will calculate what will be the procedure to determine the distance between these two planes. So the question was calculate the distance of the plane 2, 2, 2 from a parallel plane passing through the origin of a cubic unit cell of side A. So if you see, if we suppose this is a cube, and this is the, suppose this is the origin of the cube, 0, 0, 0. This is x-axis, this is y-axis, and this is z-axis. The question says, calculate the distance of the plane 2, 2, 2 from a parallel plane passing through the origin. So if you see the plane 2, 2, 2, so it will intersect the x-axis at x by 2, y-axis at y by 2 or b by 2, and z-axis at z by 2. So if you see, if you take uh, along x-axis, it is a, then it will be a by 2, and it is c by 2, and it is b by 2. So the plane will be like this. So this is the plane that we are talking about. This plane represents 2, 2, 2. And we need to find out another plane which is parallel to this plane. So this plane has, so there is certain distance between these two planes, and that another plane passes through this point 0, 0, 0, that is origin. So this is simply, if you see, if you draw a normal to this plane, this is the distance d. So this distance is nothing but the interplanar distance between the two planes, which are Miller indices 2, 2, 2. Because since 2, 2, 2 means a by 2, a by 2, b, a by 2, b by 2, c by 2, and the same plane which is parallel to the plane 2, 2, 2, and it is passing the origin. So this distance d, that is the distance from this origin to the normal that we have drawn. The length of this normal starting from origin to this plane having the Miller index 2, 2, 2 is nothing but the interplanar spacing of the plane which has Miller indices 2, 2, 2. So this d is nothing but interplanar spacing, and we know from the formula the interplanar spacing of a sets of parallel planes, they have, if they have Miller indices h, k, l in a cubic system, is given by a by h square plus k square plus l square root over. So if you put the values, it will be a by 2 square plus 2 square plus 2 square root over, which is a by root over of 12, that is nothing but a by 2 root 3. This is the correct answer. The option is option B. So there are two planes. One is, this is 2, 2, 2. Again, this plane is parallel to it and will passing to origin. So this plane will be also having the Miller indices 2, 2, 2 if we shift the origin from here to here. So this is the distance. Suppose if we suppose we will define the origin somewhere in different position. So with respect to that new origin, this plane will be again having Miller indices 2, 2, 2. So if we see, this is the distance between these two planes, that is d, and this d is given by the formula of interplanar spacing only, which is a by h square plus k square plus l square root over, which will be a by root over of 12, that is a by 2 root 3. So the correct option will be option B, that is a by 2 root 3. Is this clear to you?
Yes, sir.
Okay, so we will move to the fourth question. The question says, a crystal reflects monochromatic X-rays strongly when the Bragg's angle for a first order reflection is 15 degree. What are the Bragg's angle for the second and third order reflections of the same type? These
It's
are the
not
options. Option
displayed,
A.
sir.
Now, is it visible?
Okay, sir.
Okay, so The question says a crystal reflects monochromatic X-rays strongly when the Bragg's angle for a fast order reflection is 15 degrees Celsius. What are the Bragg's angle for the second and third order reflection of the same type? The options are option A 21.16 degree, 45.3 degree, 31.17 degrees, 50.9 degree. Option C 42.33 degrees, 65.9 degrees, and option D 47.19 degrees, 72.5 degrees. These are the four options. We have we are given with the fast order reflection occurs at 15 degrees Celsius. So what will be the second and third order reflection? Also here we don't know the value of X-ray wavelength. So the wavelength of X-ray we don't know. The wavelength of used X-ray we don't know. We just know that the fast order reflection occurs at 15 degrees Celsius. So first from the given information that we have in the question, we will first calculate the wavelength of the X-ray and then we will put the same wavelength of the X-ray to calculate the Bragg's angle for second and third order reflection. So I'll give a few minutes to try this question and then I will discuss. So are you able to calculate what will be the angles for second and third order reflections?
This is 31.17 and 50.9.
Yes,
Option
absolutely
B.
correct. So the option B will be the correct option. So as I told you, first we will calculate the wavelength and then corresponding to that wavelength, we will calculate the second and third order reflections. So the question is given for first order reflection, the angle is 15 degrees. So the Bragg's refraction law says 2d sine theta is equals to n lambda. So n is equals to 1 for first order reflection. Theta is 15 degree given. Then if you calculate 2d sine 15 is equals to lambda. Then lambda by 2d is equals to sine 15 degrees, that is 0.2588. So this is the value of lambda by 2d. So although we don't know explicitly the value of lambda and d, we will only be needing the value of the ratio lambda by 2d, because if you see in the second order reflection, same 2d sine theta is equals to n lambda is equals to 2 lambda. So sine theta will be 2 lambda by 2d. So this lambda by 2d will again appear here, and similarly for third order reflection, 2d sine theta equals to n lambda, that is 3 lambda. That implies sine theta will be 3 lambda by 2d. This will again appear. So if you put the values, it will be 2 into the value of lambda by 2d you have already calculated. It is 0.258. So 0.258. That implies theta is equals to sine inverse 0.258, means it is 0.516, which is if you calculate the values, 0.5 sine inverse 0.516 will give you 31.17 degrees. So this is theta 1. Similarly, for third order, theta will be sine inverse 3 lambda by 2d, that is sine inverse 3 into 0.2588 will be sine inverse 0.774, which will be 50.9 degrees. So theta 2 is 50.9 degrees. So the correct option will be, for second order reflection, theta 1 is 31.17 degree and theta 2 is 50.9 degree. So the correct option is option B, 31.17 and 50.9. So the first order reflection value was given. So from using that equation, the condition, we got the value of the ratio lambda by 2d, and from the lambda by 2d value, we got the Bragg's angle corresponding to second and third order reflections. I hope this is clear to you. Then we will move to the fifth question. The question says, copper, which has an FCC structure, has a lattice parameter of 3.61 degrees, sorry, 3.61 angstrom. The first order Bragg's reflection from 111 plane appears at an angle of 21.7 degree. Determine the wavelength of X-ray used. The options are option A 1.54 angstrom, 1.79 angstrom, 1.91 angstrom, and option D 1.32 angstrom. So this is pretty much straightforward question. All the information required to calculate the unknown value is given. We know according to Bragg's law of diffraction, 2d sine theta is equals to n lambda. N is 1 because it is given as first order. Then 1, 1, 1 plane is given. HKL value we know. So from the HKL value, we can calculate D. D is A by H square plus K square plus L square root over. And A is also given. The lattice parameter is 3.61. So A is 3.61 Armstrong. And again, the value of theta is given. The value of theta is 21.7 degrees. So we know all the values, only the wavelength of X-ray is to be calculated. So simply if we put all the values, we will get the answer. So please calculate and tell me what will be the correct answer.
One point 54 angstrom unit.
Yes, so if you put all these values, so D we can calculate. D will be 111 is A by 1 square plus 1 square plus 1 square root over. Then it will be A by root 3. Then 2D sine theta is equals to n lambda. That implies sine theta is equals to n lambda by 2d. N is 1. So lambda will be 2d sine theta, that is 2 into a by root 3 into sine 21.7 degrees. So if you put all these values, lambda will be 1.54 Armstrong. If you put A as 3.61 Armstrong, the value of lambda will be 1.54 Armstrong. So the option A is the correct option. That is, the wavelength of X-ray used is 1.54 Armstrong. So we will move to the sixth question. Now these are the questions. So this is a pretty important question that is again based on this atomic form factor, atomic structure factor that I was talking about in the previous week. A, a powder pattern is obtained from an FCC crystal having lattice parameter.
Not visible, sir.
Okay, is it visible now?
Okay.
Okay, a powder pattern is obtained from an FCC crystal having lattice parameter of 3.52 Armstrong using X-rays of wavelength 1.7 Armstrong. Determine the family of planes corresponding to its lowest and highest reflections. So we need to determine the family of planes that corresponds to its lowest reflection and highest reflection. Consider only first order Bragg's reflection. So we need, so in an X-ray diffraction spectra, there are different peaks. So we will consider only first order Bragg's reflection and correspond to those first order reflection. What will be the lowest and highest reflections if we use the wavelength of the X-ray 1.7 Armstrong and the powder pattern which is used for characterization as an FCC crystal having the lattice parameter 3.52 Armstrong. So the options are option A 111 and 222. Option B 202 and 113. Option C 420 and 422. Option D 202 and 420. So these are the four options. We need to find out what will be the correct answer that corresponds to the lowest and highest reflections. So the lattice parameter A is 3.52 angstrom and the wavelength of X-ray used is 1.79 angstrom. So I'll give a few minutes to think about this question. This is an important question and it underlies some concepts behind it that we will discuss. But first you try it and then we will discuss how we will solve this problem.
Sir, explain it this one, sir.
Okay, so if you see, we were also talking about the same things in the previous week. So since in the question it is given, it is an FCC crystal, and in case of an FCC crystal, only those sets of planes whose Miller indices are all even or all are odd will only show the diffraction peaks in the X-ray diffraction spectra. So if you see in all these options, 111 and 222, see 111 means all are odd and 222 means all are even. So in case of an FCC crystal, only those sets of planes which have the Miller indices which are all odd or all even, only those Miller indices or those sets of parallel planes will give you X-ray diffraction spectra in the X-ray spectrum. So if you see, initially the if you see the values that are given us initially, the lattice parameter A is 3.52 angstrom and lambda is also given. So for first order Bragg reflection, to d sine theta is equals to n lambda. Then two into a divided by h square plus k square plus l square root over sine theta is equals to lambda. Lambda is also given again. So sine theta will be equals to lambda by 2 into h square plus k square plus l square root over divided by a. That is sine theta is equals to 1.79 divided by 2 into 3.52 h square plus k square plus l square root over. Because a is 3.52 and lambda is 1.79. So if you calculate this term, it will give you 0.2543 into h square plus k square plus l square. Is not it? So if you see in the left hand side, the value is sine theta. So can you tell me what will be the maximum value of sine theta?
1.
1. So sine
Yes.
theta value can never be greater than 1. So if you see, we always know the first peak corresponds to 1, 1, 1. So if you see, we will first list out the planes that will give you the X-ray spectra. So these are the HKL values that will give the X-ray spectra, and these are the values of h square plus k square plus l square, because we need this h square plus k square plus l square value, so that if you multiply this value, it will give us a sine theta value, and this value should not exceed 1, because if it exceeds 1, then there will be no peaks. Only the previous plane will give you the peak, because that is satisfying the value of the sine theta that is less than 1. So the first member of the group will be 1, 1, 1, because all are here even, sorry, all are here odd, 1, 1, 1. So corresponding to this 1, 1, 1, the value of h square plus k square plus l square will be how much? 3. Then we need to find out the sine theta, that is 0.2543 into this h square plus k square plus l square root over. This is sine theta will be 0.25 into root 3. So 0.25 into 1.732, that is 0.44. So this is less than 1. So this will be appearing in the X-ray spectra, is not it?
Yes. Yes.
Then what will be the next member in this HKL series? You should remember that we
2.
will next means what will be the next higher value of h square plus k square plus l square. So what will be the next member?
2, 2, 2.
Sorry,
Triple 2.
no. If you see 2 to 2, 2 to 2 will be 2 square plus 2 square plus 2 square. That will give you 12. H square plus k square plus l square equals 12. But if you see, if you take 0, 0, 2, then h square plus k square plus l square will be 4. Only 2 square. So in this way, if you consider the next members, then the next will be 0, 2, 2, because here all are even. It will be 8. Then the next member will be 1, 1, 3. Here all are odd. It will be 9 into 9 plus 1 plus 1, 9 plus 2, that is 11. Then the next member will be 2, 2, 2, that is 12. Now you get it, how we are calculating, how we are getting these plane values or the Miller indices sets.
Sorry, sir. Can't
Now you
understand.
can understand how we are calculating why next will be 0, 0, 2, not 2, 2, 2. Because for 0, 0, 2 all are even, and h square plus k square plus l square is 4. So the next higher value will be 8. In between there will be no value, because we also need to see the values of the sets of HKL values we are taking. All should be either even or all should be either odd. So after 2 to 2, what will be the next values, can you say?
Mm,
It will be either 224 or 311 or 331, because it is here there is 1 3, so the next will be either 133 or it will be 004. So
So
which will be the next?
how can we take these planes? Can you explain, sir? 133,004 like that. Is there any rule?
No, no, I told you na, according to the geometrical structure factor principle, only these planes will show you the peaks. That is, for those planes, the HKL value should represent all HKL are either even or either odd. You need to know this concept.
I, so even or odd for only FCC, otherwise BCC, SC also same.
No, no, but for simple cubic, all sets of plane will give you the diffraction peaks. For BCC, the conditions are different. For FCC, again, the conditions are different.
Okay.
For,
I don't have idea, sir, about this one. Okay.
okay, so let me explain you. So if you see,
Um,
in the lecture you have na, structure factors for simple cubic, for face center cubic, for body center cubic. So see, if
yes,
you
sir.
see for actually there is a formula. The formula is
Hmm.
uh, the formula basically represents the intensity, and for the remaining values we will be getting the intensity 0, and for the other values we will be getting the intensity, there will be no non-zero value. That's why we will be having some intensities. So if you see, generally what we this is called a geometrical structure factor. If you can follow the lectures, geometrical structure factor. So suppose the radiation, the amplitude of the radiation that are scattered by the entire unit cell, that is given by F, which is a function of H A L, will be summation or I Fi. Fi is the atomic structure factor, and then E I phi I. So this phi I, it depends upon the type of structure, that is whether it is simple cubic or body center cubic or face center cubic. So corresponding to these values, whether this value is so e to the power. So now this is, if you see there is a formula na, exponential 2 pi I will be having some values.
Hmm.
1 minute.
Uh,
Yes, so this this will again give you, it will be summation j equals to 1 to m n j f j exponential, it will be 2 pi I h x j plus k y j plus l z j. So this HKL are the Miller indices, and x, y, z are the coordinates of those lattice points. So for simple cubic, we have only one lattice point per unit cell. So this one lattice point is the origin, that is 0, 0, 0. But for body center cubic, there are two lattice points. This is 0, 0, 0, and another is half, half, half.
half of.
Can you get it?
Yeah.
Then similarly for face center cubic, so if you calculate for simple cubic, what will be the value? So let me add another slide. So for simple cubic, we know the value of e to the power, but this value is odd, and then I pi, this will be minus 1, e to the power, this value is even, and then I pi, this value is 1. Is not it? So if you
Yes,
see,
sir.
for simple cubic, if you calculate, capital F will be small f e to the power I, then 2 pi, this is the formula, I 2 pi I h xj kyj and lzj. So your x, y, z are 0, 0, 0 for simple cubic. So it will be 2 pi into h into 0 plus k into 0 plus l into 0. So f into e to the power 0, that is f. So this is not equal to 0. So now you see this expression f, this expression capital F doesn't depend upon the values of HKL, because here since it is being multiplied with zeros, so for all scattering planes, that is, this is independent of HKL values. So all HKL combinations in simple cubic will give you diffraction peaks in X-ray diffraction. Now you got it?
That means uh, for any plane is, sir, I can't understand last one. Independent of h scale means what here, whatever be the Miller indices, its value is same. Huh?
So whether it is 111, 1 or 2, 113, 121, 123, all these planes will give you diffraction peaks in simple cubic, because these HKL values are not coming in the expression of F. This F represents the intensity. So if F is amplitude, then intensity will be proportional to F square. Is not it?
Okay. Yes, sir.
Then if you calculate the same thing for body center cubic, for body center cube, there are two atoms. So one is at origin 0, 0, 0, and another is at the middle, that is half, half.
Off.
This is not body center. This is sorry, for body center, this will be half, half, half. So if you calculate the value of F, there is summation. So summation, if you remove the summation, then there one term will be for 0, 0, 0, another term will be for half, half, half. So it will be F e to the power 2 pi I 0 into h plus 0 into k plus 0 into l plus f e to the power 2 pi I h into half plus k into half plus l into half. Then this will be f e to the power 0 plus f e to the power 2 pi I h by 2 plus k by 2 plus l by 2. Is not it? Then
Yes, sir.
the f will be, if you take this small f common, then it will be e to the power 0 is 1, 1 plus e to the power I pi h plus k plus l. So now, if this h plus k plus l is even, like this formula we had, na? Odd, if the I pi multiplying factor is odd, then the value will be minus 1. If the I pi multiplying factor is even, then the value will be plus 1. So here, if this scale value is odd, then this value will be minus 1. Minus 1 plus 1 will give you 0. Got it?
Odd minus minus. Okay, okay. Okay, odd. If it becomes odd, that time total value becomes zero.
Exactly. So if the sum of the values h plus k plus l is odd, then this will become minus 1. Then 1 minus 1 will be 0. So f will become 0 for h plus k plus l equal to odd. Got it?
Yes, sir.
Then if h plus k plus l is even, then this value will be 1 because here we have mentioned it exponential even I pi will be 1. So then this will be 2f if h
2m.
plus k plus l equals to even. So since this amplitude is coming 0, then for those planes who have h, k, l values whose summation is odd, then those values, those planes, so for h plus k plus l odd, there will be no peaks. For h plus k plus l even, there will be peaks. And this is for body center cubic. So example, if we take for 110, the sum is even, 1 plus 1 is 2. So it will show you the Bragg's peak. But for 100 plane, the sum is odd, so it won't show you the Bragg's peak. Now you get it?
Yes, sir.
Okay, so then for face center cubic, similarly, you can say there are 4 points. So for face center cubic, the 4 positions are for FCC. There are four lattice there are 4 lattice points per unit cell. So these 4 points have coordinates 0, 0, 0, half, half, 0. That is the middle of the face. So half, 0, half, and 0, half, half. So these are the 4 sets of coordinates. So if you similarly put the formula, then it will be f e to the power 0, that is 2 pi I into 0 h into 0 plus k into 0 plus l into 0. Then it will be f into e to the power 2 pi I h into 1 by 2 plus k into 1 by 2 plus l into 0. Then plus f e to the power 2 pi I 0 into, sorry, h into 0 plus k into 1 by 2 plus l into 1 by 2 plus f exponential 2 pi I h into 1 by 2 plus k into 0 plus l into 1 by 2. So these 4 values we have taken 4 points or 4 terms. Now you get it?
Yes, sir.
Then f will be, if you take small f common, there will be 1 plus exponential I pi, again this half or half. So this L will be, this will be 0, this will be 0, and this will be 0. So it will be exponential I pi h plus k plus exponential I pi k plus L plus exponential I pi h plus L. Now we get it.
Yes.
Then suppose we will take all are odd. Suppose one is even or one is odd, then what will happen? So, so suppose A is odd and B is even. Then their sum will be odd, is not it? Suppose H is even and K is even, then H plus K will be even. But if any one of them will be odd, then all these values will be odd. H plus K will be odd. You are getting my point?
Yes, yes, sir.
Now see, the capital F is small f 1 plus exponential I pi h plus k plus exponential I pi k plus l plus exponential I pi l plus h. You understand up to here, up to this
Yes,
point,
sir.
you understood how we are calculating.
I
Then
understood.
if we take, suppose h, k, l all are odd, and H, K, L all are even, then H plus K will be even, K plus L will be even, L plus H will be even. Is not it? Whether both of them are odd or both of them are even, the sum will give you an even number.
Yes, sir.
So in this case, F will be 4F because it will be 1, it will be 1, it will be 1. So F will be 4F. So the intensity will be 16F square. But if any one of them is odd, then it will, then what happens? Suppose H is odd and K, L are even.
Oh,
Then H plus K will be odd and H plus L will be odd,
order.
but K plus L will be even. Is not it? Then if you see K plus L even means
Yes, sir.
this will give you plus 1, but other two will give you minus 1 and
All are
minus 1.
cancelled.
Then 1 minus 1, 1 minus 1, or will be cancelled. So F will be 0. So intensity will be 0. So the only available combinations are all scale are either odd or all scale values are either even. So corresponding
Even.
to these, we have different planes. So in the question that we are discussing, let me go back to the question. Now we get it how we are taking all odd values will be all odd or
Yeah.
all even values will be present but not other values. So here
I
we
clearly
have taken
understood.
all. So here we have taken all odd values or all even values. So
Even
and
value.
all these values will be arranged in increasing order of their h square plus k square plus l square value. So the first will be 111, then the next will be 002, then the next will be 022 because the next higher value of h square plus k square plus l square is 8. And then the next higher value will be 11, which corresponds to 113, then 222, then 133, like that. So now you tell me whether it will be 133 or 004, which will be the next after 12, which will be the next, whether this one or this one.
Sorry, sir. 113 or other one?
004.
113, sir. First, after then 004.
No,
5 root.
this is
Sir, sorry.
133. Na?
First 004, sir. After then 113 because it is a square root of
Exactly. So
2
this
means
is 16, but here it is 9 plus 9 plus 1, that is 19.
11.
So
Yes,
16
sir.
will come after 12 and then 19. So 004 will come here, not here. So now,
Ah,
corresponding to these values, we will calculate the value of sine theta. So for first case, we calculated 0.25 into root 3. So this was 0.44, that was less than 1. So for root 4, 0.25 into 2, 0.25 into 2, 0.5, which is again less than 1. Then for 8, 0.25 into root 8, which is 0.719. It is again less than 1. Then for 11, 0.25 into root 11, this will be 0.843, which is again less than 1. Then for 12, 0.25 into root 12 will give you 0.88, which will be again less than 1. Then for 16, that is 004, 0.25 into 4. Sorry, it's not 0.25, it's 0.2543. So 0.2543, 0.2543 into 4, it is 1.01, is not it? It is greater than 1.
yes, sir.
You are getting my point?
Yeah. Yes, sir.
So corresponding to these HKL values, in the question we just, in the previous discussion, we just showed sine theta can never be 1. So these HKL values which result in the value of this right hand side greater than 1, they won't contribute or they won't appear. So the last number will be this, which will be having value less than 1. So here, if you calculate sine theta is 0.2543 into h square plus k square plus l square root over. So here it is 3. So 0.25 into root 3 it is 0.44, which is less than 1. Similarly, 0.2543 into root over of 4, 0.5. Then 0.25 into root over of 8, 0.719. Then 0.843, then 0.88. But for 004 case, for 004, the value is 16 root over is 4. So 0.2543 into 4 is greater than 1, which is 1.01. So this 004 will not be appearing for this particular, because
Brax reply.
for this particular condition, that is for 1.79 of wavelength and 3.52 of lattice parameter, the sine theta value is being greater than 1, which can be possible. So the first member will be 111. Then what will be the last member?
222.
The last number will be 222, because 004, the value is giving us greater than 1, which is not allowed. So the
Yes,
correct
sir.
option will be option A, that is 111 and 222. Now you understand it perfectly?
Yes, sir. Perfectly
Okay,
understood.
so we will move to the next question. So question number 7. Question number 7 says, find out the reciprocal lattice of a two-dimensional Bravais lattice for which a set of primitive vectors are given by a1 vector is a1x I cap plus a1y j cap, and a2 is given by a2x I cap plus a2y j cap. The options are option A, B, C, D. You can see the options. So these are the four options. These are some complicated expressions that will come if you calculate by putting the values of a1 vector and a2 vector. So these are the lattice parameter in direct space, and we need to find out the lattice parameter in reciprocal space. So there are some sets of formulas which we will be applying to calculate the value of a1 star and a2 star. So these are the values of lattice parameter in reciprocal lattice. These are in direct lattice. So we will put the formula and calculate the values of a1 star and a2 star, and tell me what will be the correct option or what will be the correct expression for lattice parameters. You know there is a formula for calculating the parameters of lattice parameters of
Yes, sir.
reciprocal lattice from direct lattice. The formula says a star will be 2 pi b vector cross c vector divided by a dot b vector cross c vector. B star is 2 pi c vector cross a vector divided by a dot b cross c, and c star is 2 pi c means it will be a cross b divided by a dot b vector cross c vector. So these are the formulas. So here a1 a2, so we will put this as a1, so this is a2, this is a3, like that. So B is our A2, A is A1, and C is A3. So we will use these formulas and we will calculate what will be the expression for the reciprocal lattice vectors. So I'll give you a few minutes to calculate, and then I will calculate it completely how will be the what will be the expression, what will be the correct expression for the lattice parameters.
Sir, explain this one, sir.
So you see, I just told you in the expression of A1 star and A2 star, we are writing 2 pi B vector cross C vector. So we have to assume some value of the C vector. So since C vector is not given in this question, so simply we can assume it as K cap, because since all are written in terms of uh, I cap, J cap, so simply we can assume A3 vector as K cap. So we have A1 vector as A1x I cap plus A1y J cap. A2 vector equals to A2x I cap plus A2y J cap, and A3 vector equals to K cap. We assumed it. Then, according to the expression, A1 star will be 2 pi A2 vector cross A3 vector divided by A1 vector dot A2 vector cross A3 vector. Is not it? Or A1 vector cross A2 vector dot A3 vector, or whether it is A dot B cross C or A cross B dot C, the value will be unchanged. So we can write it as 2 pi A2 vector cross A3 vector divided by A1 vector cross A2 vector dot A3 vector. So now if you calculate A1 vector cross A2 vector, because this is the A1 vector cross A2 vector, then the value will be A1x into, sorry, A1x I cap plus A1y j cap cross A2x I cap plus A2y j cap. This is I cap. The value will be I cap, j cap, k cap, A1x, A1y 0, A2x, A2y 0. So it will give us k cap A1x, A2y minus A2x, A1y. Is not it? So A1 vector cross A2 vector is equals to k cap A1x, A2y minus A2x, A1y. So we got the value of k cap is A1 vector cross A2 vector divided by A1x, A2y minus A2x, A1y. Then again if we calculate A1 vector cross A2 vector magnitude, then it will be only A1x, A2y minus A2x, A1y. That is the square and root over. So it will again give you same value A1x, A2y minus A2x, A1y. So now if you again calculate the value of, so here this value we can calculate later, because this value will be only A2 vector dot, uh, 1 minute. So this value, uh, again we need to calculate the value of A1 vector cross A2 vector dot k cap. So this is this denominator value we can calculate A1 vector cross A2 vector dot k cap. So again this value will be A1x, A2y minus A2x, A1y, which will be again A1 vector cross A2 vector. magnitude. Is not it? If you see, this value is a1x a2y minus a2x a1y. Simply this is k cap dot k cap. Then k cap dot k cap will be 1. So again the value will be same. So this value is equals to a1 vector cross a2 vector magnitude. So now if you put all these values, what is the expression for a1 star? The expression for a1 star will be 2 pi a2 vector cross k cap divided by a1 vector cross a2 vector dot k cap. If you put the value of k cap here, that k cap, the value of k cap is a1 vector cross a2 vector divided by this value is a1 vector cross a2 vector magnitude. a1 vector cross a2 vector magnitude. Then this will be 2 pi a2 vector cross a1 vector cross a2 vector divided by a1 vector cross a2 vector magnitude into a1 vector cross a2 vector magnitude. So we put this value of k vector here or k cap here. Now we know a vector cross b vector cross c vector is a vector dot c vector into b vector minus a vector dot b vector into c vector. This is the formula for vector algebra. So if you put this formula, it will be 2 pi a2 vector dot a2 vector into a1 vector minus a2 vector dot a1 vector into a1 vector divided by a1 vector cross a2 vector mod square. Then finally we can write it as a1 star equals to 2 pi divided by a1 vector cross a2 vector mod square. a2 vector dot a2 vector will be a2 vector mod square into a1 vector minus a1 vector dot a1 vector into a2 vector. So this is the value of a1 star. So if you see the formula, if you see the answers, this a1 star, this is the correct formula. Similarly, by using the same procedure, you can again find out the value of a2 star, and the value of a2 star will be pretty much similar. It will be 2 pi divided by a1 vector a2 vector mod square. Here it was a2 vector square, here it will be a1 mod square into a2 minus a2, here it is a1 into a2, sorry, a1 into a2 will be a2 into a1 into a1. So this is the correct answer, and the correct option is option A. Is it clear to you?
Okay, sir.
So in the question, a1 and a2 vector values were given. So we assumed another value of a3 vector we need because we need the value of a3 vector. And then during the course of calculation, we converted the value of a3 vector, that is k vector, in terms of a1 vector and a2 vector. So we converted the value of this k cap in terms of a1 vector and a2 vector, and in the place of the expression, and during the expression in place of k cap we put the same values of a1 vector cross a2 vector divided by a1 vector cross a2 vector magnitude. So if you put all these values and calculate, and there is a formula for vector triple product, that is a vector plus b vector cross c vector. The formula is A dot C into B minus A dot B into C. So this formula, if you put, the bracketed term will be like this. So the expression of A1 will be like this, and the expression of A2 will be like this. So
If suppose,
these were,
sir, A2 is not, sir, or not, A2 is not given, A1, A3 is given. So that time
yes,
A2 can be taken as J cap.
yes, we can take as J cap, and then during the calculation, we will convert A2 in terms of A1 and A3 because we have assumed
Yes.
it. So it is always better to convert the values in terms of the existing values. But if you are
Okay.
not assuming, you can calculate because during the expression, you need the values of all the three vectors, A1 vector, A2 vector, A3 vector.
Okay.
Then we will move to the next question. The question now, all the questions that I will be doing, all these questions are again based on the same formulas, but in that case there were some expressions, but here there are some numerical values. So in place of a1, a2 or a1x, a1, a1x, a2x, a1y, a2y, there are the values. So here the question says a two-dimensional Bravais lattice has the primitive vectors in nanometer. A1 vector is 0.4 I cap, A2 vector is 0.1 I cap plus 0.2 J cap. Compute the primitive vectors of the reciprocal lattice. Option A, A1 star is 5 pi, J cap minus 2 I cap, and A2 star is 5 pi J cap. Option B is A1 star is 5 pi by 2, 2 I cap minus J cap, A2 star is 10 pi J cap. Option C, A1 star equals to pi I cap, A2 star equal to pi J cap. Option C, or sorry, option D is A1 star is 2 pi I cap minus J cap, A2 star is 2 pi 2 I cap minus J cap. So the expressions are same. You just need to put the values to that expressions and the correct value we can easily calculate. So you just need to remember the expression. So these expressions we will put the values of a1 vector, a2 vector, and we will get the correct answer. So I'll give a few minutes to try this. So please calculate and tell me what will be the correct option. So did you calculate?
I check. It is. I don't have correct calculator, so that I'm manually I am doing,
No,
sir.
but calculator I don't
Tell
think you
me,
need
sir.
for this. These are some small values, na? So
Mm.
see, uh, in the expression, we need the value of A1 vector cross A2 vector magnitude and the value of A1 vector mod, A2 vector mod, and then A1 dot A2. So we have A1 vector is 0.4 I cap and A2 vector is 0.1 I cap plus 0.2 j cap. So A1 vector cross A2 vector magnitude, if you calculate, it will be I cap, j cap, k cap 0.400, 0.1, 0.20. So it will be I cap into 0, j cap into 0. So it will be k cap into 0.4 into 0.2. So it will be 0.08 k cap. So A1 vector cross A2 vector is 0.08 k cap. So their magnitude will be A1 vector cross A2 vector mod will be 0.08 square. So one value we got. Then another value is A1 vector mod, which is 0.4. A2 vector mod is 0.1 square plus 0.2 square root. So A2 vector mod square will be
0.05. Square root of 0.005.
0.05. That is
Square
1
root.
by 20 we can say again. So if you put these values, because in this expression, so what will be the correct expression? So the expression of A1 star was 2 pi divided by A1 vector cross A2 vector mod square, then A2 vector mod square into A1 vector minus A1 vector dot A2 vector into A2 vector. So it will be 2 pi divided by 0.08 square, then 1 by 20 into 0.4 I cap minus 0.04. A1 vector dot A2 vector is 0.04 because 0.4 into 0.1 is
Yes.
0.04. Then
0.04.
0.1 I cap plus 0.2
Plus
j cap. So if
okay.
you calculate it, it will give you height pi by 2, 2 I cap minus 2 I cap minus j cap. Are you getting it?
Yes, sir. Up to now, okay. I will finally answer. I am calculating. Okay, sir.
Finally answer
After
means
simplifying, uh, so up to
this will be the value.
above 5 by 2, I got it. Above 5 by 2 to 2i minus j, na. Above that one, up to
Yes.
now, I calculated. After then, I have to calculate it.
So
Okay,
you
sir.
see A1 star is like this. So A2 star will be again 2 pi divided by 0.08 square. Here it will be A1 vector magnitude. So A1 vector magnitude will be 0.16. 0.4 square means 0.16. Then
And
0.1 I cap plus 0.2 j cap minus 0.04 into 0.4 j cap. Sorry, I cap. This is A1. If you calculate it, it will be 2 pi divided by 0.08 square So it will be 0.016 I cap plus 0.032 J cap minus 0.016 I cap. So if you see 0.032, 0.016, so they can be uh, neglected. So it will be sorry, not like this. So this gets cancelled out. So 2 pi into 0.08 into 0.08, 0.032 J cap. So here 0.08 and 0.08, so it will be 4. So it will be 2 pi into 4 into 100 divided by 8. It will be not 4, it will be 0.04. 0.48 into 0.04, so 0.4. It will be into 10. So it will be 10 and 4 to 8. It will be 10 pi j cap. So this is A2 star vector is 10 pi j cap and A1 star vector is 5 pi by 2, 2 I cap minus j cap. So if you see the options, 5 pi by 2, 2 I cap minus j cap, and A2 is 10 pi j cap. So the correct option is option B. Is this clear to you?
Yes, sir.
Okay, so with this we will end today's session, and in the next session we will solve the problems that will be again based on the 6 lectures.
Sir, I have one doubt. In the
Yes.
problem 8, sorry, in the problem 3, here
Yes.
the parallel plane passing through the origin. Okay. So that we take same plane and the distance between the plane is d. If suppose
Yes.
it is taken without origin, that time what we consider, sir?
No, no, if you see, since these planes are parallel, then all the parallel planes have same Miller indices,
Okay.
2, 2, 2. So,
Uh,
corresponding to those parallel planes, since this is origin means what? Origin means this is the point origin, and with respect to this origin, we define the plane that is 2, 2, 2. So, if the distance from origin to that plane is nothing but the separation between two planes which are parallel to each other and have the Miller indices 2, 2, 2. Because if you define another origin, then another plane, suppose if you define the origin in the plane, let me, so this was the plane and this was the origin. But if you draw origin in here in this plane, then this plane will again be 2, 2, 2. With respect to this origin, this plane again will be 2, 2, 2. So these are two parallel planes, and the distance between these two planes is the interplanar spacing. So the interplanar spacing is D, that is the formula we put A by h square
okay,
plus
sir.
k square plus l square.
Yeah, that means even though that plane, parallel plane passing through the origin or without origin, both planes are same.
No, no. Since it is passing through the origin, both have see 1, 1, 1 plane and 2, 2, 2 plane, both are parallel. You see
Without
1, 1,
passing through
1.
origin, sir.
Sorry?
Here parallel
No,
plane
no, you see
passing without origin.
1, 1. No, that's why I am explaining. Suppose one plane is given 2, 2, 2. Then these 2, 2, 2 will be again parallel to 1, 1, 1. Because if you took the common factor 2 here, it will be again 1, 1, 1. Is not it? So, but
Yes, sir.
what will be different between these two planes? The difference between these two planes will be the interplanar spacing. Because if you see, suppose this is the origin, the 1, 1, 1 plane will be here, but the 2, 2 plane will be here. So, the distance between the plane from origin to this plane, this is 2, 2, 2, this is 1, 1, 1. So the interplanar spacing is different. So for one plane, this is the interplanar spacing, but the other plane, this is the interplanar spacing. So for 2 to 2 plane, the interplanar spacing will be this, and for 1 1 1 plane, the interplanar spacing will be this. So this is D1, this is D2. So the formula is D. It is A equals to h square plus k square plus l square root over. So also, if for more understanding, you can see the lecture where the expression for this interplanar spacing has been derived. So from that way of expression or the way of deriving, you can easily understand how the interplanar spacings are calculated.
Okay.
Okay, so with this we will stop today's interaction session. So
Okay.
in the next interaction session, we will
Sorry, sir. Not understand.